Hello, good day. My name is Callanta, and I'm here in front of you for the introduction of aviation and the principles of flight. But before that, let's go on to our agendas. History of aviation, basic aerodynamics of aircraft, components of an aircraft, principles of flight. Then let's go on to the history of aviation. The history of aviation spans to the past through the future, starts from kites, balloons, to powerful engine jets and aircrafts. Aviation have a lot of pioneers through the years: Da Vinci, Hooke, Cayley, Jacques, and Charles. But the main is the Flyer. The Flyer is done by the Wright brothers. They are the main pioneers of aviation as it paves way to what we have now in our world today. Aerodynamics of an aircraft. As you can see, it contains the thrust, weight, drag, and lift. Now let's go on to what they mean. Lift is the upward force of an aircraft. Drag is the retarding force acting on an aircraft. Weight is the overall load of the aircraft that includes the baggage and the crew. And thrust is the forward force of an aircraft. Now let's go on to the aircraft rotations. As you can see, we can we can see from the figure the pitch, yaw, and roll. The pitch axis, also called as the lateral axis, as it moves from its wings. Roll axis, also called as a longitudinal axis, it runs through the nose to the aircraft to its tail. And the yaw axis, the aircraft runs vertically through the center of the aircraft. Center of gravity. The center of gravity states the point which the aircraft will balance. It determines the stability of the aircraft as it flies. Let's now go on to the parts of an aircraft. Number one, we have fuselage, the main part of the aircraft as it serves as the body that includes the pilot and its passengers. Second are the wings. These are the main supports of an aircraft. It is usually attached with the fuselage. And we have the next one is the empennage. It includes the whole tail part of the aircraft, which include the vertical and horizontal stabilizers. It also includes the rudder, the elevator, the trim tabs as part of it on the tail. Next, we have the landing gear. These are the main supports of the aircraft on its lower part. These are used whenever the aircraft is landing, taxiing, or going through departure. Lastly, of the components of an aircraft, we have the power plant. It includes the engine of the aircraft, which provides it to fly and maneuver through the air. Next, we have the principles of flight. We have discussed the movement of aircraft and its basic forces. Now we are here to examine the laws and forces acting on an aircraft. Structure of the atmosphere contains 78% nitrogen, 21% oxygen, and 1% other gases. The elements present outside of our reach are far different and consist of air-like fluid that is able to change in shape and form. Atmospheric pressure. We know air is light, yet it has mass and is affected by the attraction of gravity. Therefore, like other substances, it has weight and has force to go with it. Air is like a fluid substance. Air is a fluid substance. Force is present in any area, so that's why it is called atmospheric pressure. Now let's move on to the atmospheric density. Both temperature and pressure change in altitude, but on this case, pressure drops more rapid as altitude increases, not much with temperature. With that, density decreases with increased altitude. The density of an air has significant effects on the aircraft's performance because as air becomes less dense, it reduces power, power because the engine takes in less air, thrust because a proper propeller is less efficient in thin air, lift because the thin air exerts less force on the airfoils. Let's go on to the theories regarding the lift of an aircraft. First, we have Newton's first law. Every object persists in its state of rest or uniform motion in a straight line unless it is compelled to change that state by forces impressed on it. Second law of Newton. Force is equal to the change in momentum per change in time. For a constant mass, force equals mass times acceleration. And in Newton's third law, for every action, there is an equal and opposite reaction. Same with airplanes. Whenever it moves, there's always a different reaction. Lastly, we have Bernoulli's principle. States that as the velocity of the moving fluid, liquid or gas, increases, the pressure within the fluid decreases. This principle explains what happens to air passing over the curved top of the airplane wing. Let's look on to the airfoil design. The airfoil design consists of four main parts. Number one is the chord line. It is the straight line connecting the endpoints of the mean camber line. The mean camber line means locus of all points equidistant from top and bottom of airfoil. Leading edge, the forward points of the mean camber line, and the trailing edge, the most rearward points of the mean camber line. And that is my introduction to aviation to you all. Thank you for listening and goodbye.